Math 161, ellipse, third example of an ellipse. Again, the standard equation for an ellipse with center HK, x radius A, y radius B is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Here's another example here. We have 4x squared plus 4y squared minus 4y equal 8. X squared and y squared terms have the same sign, so it's probably going to be an ellipse. It might be no solution, but we're going to try to match it to the equation for an ellipse. And the y terms are already together, so we don't need to rearrange the order of the terms here. We want to factor out the common factor from the y terms. There's a common factor of 4. Divide each term by 4, we get y squared minus 1y. We don't need to factor anything from the x terms because there's only one x term here. And then we want to make the y term into a perfect square. We take half the coefficient of y, half of 1 is a half, and square it. 1/2 squared is 1/4. So we want to add 1/4 to the y term to complete the square. We need to add the same number to the other side in order to make the equation equivalent to the original equation. So the 1/4 that we're adding is inside parentheses with a 4 on the outside. So really we're adding 4 times 1/4, and we do that to the right side of the equal sign. Well, 4 times 1/4 is 1, so this will be 8 plus 1, which is 9 here. Okay, so we have a 9 on the other side, and we want to then factor the y terms. Y times y is y squared. We need two numbers to multiply 1 to 1/4 and add up to -1. The numbers that work are -1/2 and -1/2. -1/2 times -1/2 is 1/4. -1/2 plus -1/2 is -1. And then, so now we can write this more compactly with using an exponent. Y minus a half times y minus a half is y minus a half quantity squared. So the new equation is 4x squared plus 4 times the quantity y minus a half squared equals 9. And now we can get rid of the coefficients of x squared and y squared if we divide by 4. There's a common factor of 4 there. And if we divide by 4, the 4's will cancel. We'll have x squared plus the quantity y minus a half squared equals 9/4. And you can actually identify the shape here already. It's not quite the standard form for an ellipse, but you notice because x squared and y squared have the same coefficients, it's most likely going to be a circle rather than, circle is a special kind of ellipse. But if it's going to be, when x squared and y squared have the same coefficients, you don't really have to get this 1 on the other side. You can identify the coefficients, the features of the graph already. So we want to write this x squared as x minus 0 squared because there's no x term. So we can write as x is the same as x minus 0 quantity squared. And then 9/4 we can write that as 3/2 squared. So this is going to be a circle. The center is going to be 0, 1/2. It's HK 0, 1/2. And the radius is going to be 3/2. Okay. We can also put this in the standard form for an ellipse. A circle is a special kind of ellipse. The standard form for ellipse, instead of an equals 3/2, we have an equals 1 here. So if we divide each term by 3/2 squared, the 3/2 squares will cancel and we'll get an equals 1 there. And now we have the standard form for an ellipse. The center is HK, would be 0, 1/2. Radius in the x direction is 3/2. Radius in the y direction is 3/2. Okay, so with that information we can sketch the graph. So the center, 0 left to right, up a half. And then if you go, the radius is 3/2. So you go 3/2 in any direction. 3/2 is the same as 1 and 1/2. You can get some more points and connect the dots in a circle. So that's the graph. Again, we could use the formula to locate the focus. Formula C is equal to square root of absolute value of a squared minus b squared. So a and b are both 3/2, so we'll have the square root of the absolute value of 3/2 squared minus 3/2 squared. A number minus itself is 0. So this is square root of absolute value of 0. Absolute value of 0 is 0. Square root of 0 is 0, because 0 squared gives you 0. So the focus will be 0 units from the center. And so if you go 0 from the center, you stay at the center. So the focus for a circle, the focus is actually the same as the center. And that concludes this presentation.